All right, Trinity Classical Academy Renegades. It is I, your fearless mathematical leader, leading the rebellion, as usual, in the fight against mathematical ignorance during these end of days or beginning of a new era, or whatever we're in right now. Not sure what God's doing, but today we're going to be talking about, if you turn with me to page 163, we're going to be talking about composite solids. So three-dimensional things, and I thought it would be appropriate to illustrate a point that I have here. So here is a picture of a paint pot that one of many that I sell. This one is a pink called Emperor's Children, and that's irrelevant. But I want you to notice we're going to be dealing with shapes that are composites. So not one exact specific shape, but maybe a shape that involves multiple different kinds of solids. So this right here, it's kind of like a cylinder. We have this bottom pot, and then we have this funky lid. This lid is actually something special. It's got a lot of empty space inside of it, and it's got I don't know what you'd call it. It's got this little like blade, I guess. Let me see if I can doodle on it. The lid attached to it has this little funnel-shaped blade that comes down about there. And when you shake it up and you open the lid, it's like a shovel spade, like the spade of a shovel, and some of your paint just kind of sits. So this is going to be the side view. So you've opened your lid, and the lid sits like that. It's got this little stopper right here that keeps it from opening too far. So the lid just goes kind of up at a 90-degree angle like that. But then it's got this little spoon thing, that juts out a bit, and your paint kind of. Let me draw this a little more accurately. So it comes out to about there, and it's like a spoon, and it's got whatever color you've got. The paint will be kind of dripping off of there, and it kind of sits in that spoon. So you can take your brush and just kind of dab a little bit from there if you want to. You can, of course, there's a little bit of a gap right here where you can kind of spoon a little bit, scoop a little bit out with your brush and lay it down on a palette or a paper plate or something, and then mix your color, like darken it with like just a tiny dab of black or a darker gray to change the tint of your pink if you are so inclined. But one of the common complaints I get, I want us to look a little bit at this shape and consider what we're dealing with here. So this shape is kind of like a cylinder. So if we were going to approximate the volume, I would say a cylinder would be the way to go, right? I'm looking at a whole bunch of them because I'm in my basement where I keep my own personal stash of paints. So I would judge that the base is about 3 centimeters across, a little more than an inch. I know it's so metric, but we're dealing with, these paints are manufactured in Europe, so it's kind of like a cylinder. And I would judge it's probably also 3 centimeters high if I'm looking real carefully at it. It's probably as wide as it is tall, and if I hold the base up next to one on its standing upright, that does look about accurate. Come on now. So we could calculate the area of this cylinder. Actually, let's go ahead and do that. Go ahead and do that. Pause. Pause. Tell me what do you think the area or the volume, the volume of the cylinder is. So we've got the area of the circle on the bottom. The radius would be 1.5 centimeters. We square that, we times 3.14 to estimate pi. Then we're going to multiply it by 3 centimeters to give the height. We get something like 21 centimeters, I believe, right? I hope I'm right. If I'm wrong, I may be wrong. I know in my previous video, I started by doing mental math in my head and getting it wrong, and several of you were like, wait, what's going on? I must be wrong because Mr. Bourgeois is infallible. I'm actually not infallible. Sometimes I make mistakes. So don't If you disagree with me, it's possible that you are correct and I am wrong. Although it's also possible that you might actually be wrong. But anyway, I'm just going to, we have to, that little spoon thing that comes down does take up quite a bit of volume. I'm just gonna level with you. The amount of paint that is in one of the smaller sizes is 12 milliliters. And a milliliter is the same as a cubic centimeter. So those two things are equal. The lid also holds some paint, or it could, but it doesn't because it's empty space. So the lid also has some volume. So now imagine if we're running, some of these things are kind of inky, they're kind of runny and thin. The thick paints, it just coats the whole side from end to end, so you can't really tell how much is in there. It's kind of tricky. But the when I ship a box of paints to people, sometimes these things are on their side. And we got the little domey lid thing. And so sometimes they're on their side and the paint fills in part of the lid. It used to be, when it's completely standing upright, I'm going to draw really just crappy. When it sits completely upright, the level of the paint looks like, oh, I got a full pot of paint. But when it tips sideways, it's like, hey, where'd all my paint go? You guys are selling me half of a jar of paint. You ripped me off. And I get people who complain who say that I opened it up, I used half of the paint, and then I sent them half of a pot of paint. Or sometimes they don't make an accusation directly against me and my character. They say, hey, it looks like this one is only half full. They must have made a mistake at the warehouse, the manufacturer must have made a mistake. No, sorry. It's just that there's empty volume here in the lid. This lid has a bunch of empty space in it, so if your paint tips sideways, it's going to make the level visibly. You're going to be looking at this and say, what is going on? Something is not right. You know, you're looking down and you're like, I don't even know what I'm trying to do. I'm drawing eyeballs. This is just creepy and not helpful. But you look at it and you're saying, this is not the amount of paint that I paid for. It actually is. I'm sorry. You paid $4.55 for 12 milliliters of paint. Maybe you should make better life choices. I don't know. But I always disparage my customers. It's one of my favorite things to do. So we're dealing with, all that to introduce, we are dealing with composite solids. A solid where we have to figure out the volume of a shape, but it's not so cut and dried. There's two pieces. This is kind of like a hemisphere. So we would take a sphere, divide it in half, and that gives us our volume of the hemisphere. And then this is kind of like a cylinder. It's about equal to a cylinder. A cylinder would be a perfect approximation. Cylinder, need another I there. So that's what we're dealing with. Pretty fun, huh? I think so. I'm glad you agree. Delete. Okay, now then. So the object is to solve real-world problems that involve composite solids. To find the volume or the surface area of a composite solid, you need to identify what basic solids we're dealing with. Next, you're going to need to find the volume or the surface area of each solid, and then add or subtract volumes to find the volume of the surface area of the composite. So two or more pieces together, you have to calculate them separately, add or subtract as needed. And this is why it's super important, like if we're dealing with something like, say, a cone, drawing is really hard. Should make Mrs. Alston teach one of these classes for me. Ask her nicely, is what I meant. Like if you're dealing with a cone, you need to know how to calculate this piece, this little rounded surface area, separately from the circle on the bottom. You need to know how to calculate the curved surface of a cylinder separate from its bases, because sometimes the bases aren't going to be included, or maybe only one base is included, or maybe only one face of a cube is included, or one face of a prism is included. If you just straight up memorize the formula for the whole thing, you will miss a couple of important, difficult questions. Let's look at example 18. A composite solid is made up of a cone and a cylinder. The height of the solid is 13 centimeters, the height of the cylinder is 7 centimeters, and its radius is 8 centimeters. Find the volume of the composite solid to the nearest cubic centimeter. So we're dealing, guys, with a cylinder and a cone. It's pretty straightforward. If they're asking us to solve the, what do they ask us? Find the volume. So asking us to find the volume. So the volume here is pretty straightforward. Looking at your book, there's a cylinder, calculate the volume of that. There's a cone, calculate the volume of that, add them together, right? So they calculate the volume of the cylinder. The cylinder is, what is with me today? The cylinder is pi radius squared times the height. And reason being, because, just to review, this is the area of the circle on the bottom. So the circle is pi r squared. We multiply that by the base times how high it is. And that gives us the volume, right? That's the formula. The area of the base times the height equals the volume for any surface like that, any solid like that that does not have a slant height. Even the ones that do have a slant height, you just add a multiplier to it, as we will see with the cone. The cone is 1/3 times pi r squared height. So the cone works similarly in that it works just like a cylinder, except it's only 1/3 as big. And we kind of explored that in earlier chapters. So we add these two pieces together. We have one piece. Let's be colorful, why not? We have one piece. We have another piece. We plus, add them together. That's the volume of the composite, right? And they go through the steps and they solve it. It's interesting. Turn the page. So now we're on page 164. We're doing guided practice, numero uno. I want you to pause. We're going to solve it. Now again, you don't have to fill in all the inky-dinky little blank spaces. If you just want to come up with the answer for A and the answer for B, go on ahead. Wiggity wiggity wow. Hit play again. You already did because you can hear me now, which means the video is playing, because if it was still paused, you wouldn't hear me. All right, so here's the solution. So here are the answers first. Number A, the volume of the composite solid is about 10,098. 10,098. 10, comma, 098 or 09 or 8. The surface area, which they didn't even give us an example about surface area, but that's okay because y'all are smart. The surface area of the composite solid is 2,525. That's 2,525, 2,525. If you got something bigger than that, it's quite possible that you included the area of the base of the cone, which is also the top of the cylinder. Let's take a look. Here's the solution. You may fast forward till you see the red triangle that I usually draw. If you got both of those answers correct. Otherwise, watch me solve it. So, number A. First of all, a composite solid is made up of a cone and a cylinder. The slant height of the cone is 25. The height of the cylinder is 15 centimeters, and the radius is 12 centimeters. The height of the solid is 37 centimeters. Use 3.14 to approximate your pi. Number A, find the volume of the composite solid to the nearest 1 centimeter. Okay. So y'all, I did not really spend much time preparing for this, so there's very likely that I might make a mistake. But I don't know about very likely. It's more likely, not very. All right, so the cylinder. Let's do the cylinder first, because the book does. Boop, 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 boop. Pi r squared times the height. So pi is 3.14. First things first, we always write our formula. So pi r squared times the height. First things first, we write our formula. 3.14 is our approximation for pi. The radius they gave us is 12 centimeters. We're going to square it. It's going to be 144. I'm just going to go ahead and write that, because squaring happens first. This is 144. I'll write my 4s like that, because touch screens are tricky. The H of our cylinder is 15. We don't want the H of the whole kit and the whole caboodle, just the kit, just the cylinder. So we just multiply this across, guys. So 144 times 15 times 3.14. This equals, oh, they left it in terms of pi. Okay. Well, that's, we're just gonna multiply it out. Equals 6,782. This will be centimeters cubic centimeters. Now the cone. Whoop, whoop, here. The cone is, the formula is the same, except it's a 1/3. So 1/3 times pi times the radius squared times the h. We have to figure out our h, because the h for the total thing was 37, but we have to subtract this 15 right here, right? So h is going to be 37 minus 15, which is 22. The radius is going to be the same as the radius of the underlying cylinder, so it's going to be 12, which means the radius squared is also still going to be 144. So here we go. 1/3 times 3.14 times 144 times 22. Once again, I'm just going to multiply straight across on my calculamatron. So 140. I'm going to leave the fraction last. So 3.14 times 144 times 22 equals that number, and then instead of multiplying by 1/3, because that's a lot of keystrokes, I'm just going to put divided by 3 equals 3315.8, but we're supposed to round to the nearest centimeter. I'm just going to round right there. Centimeters cubic. We're going to add these two together. So the final answer, I'm going to zip it over here, snaky like. The final answer is going to be those two things plus to each other. 3316 plus 6782 equals 10,098 cubic centimeters. That's a lot of drops of paint. Fun times, you guys. So that's number A. Number B. I didn't carefully enough. I'm going to carefully erase my work here just for the sake of my computer's memory and also the other reasons. Sorry, composite solid. It's like a can of beef stew wearing a dunce cap. I don't know. The surface area of the composite solid. So, you guys, the surface area. This is pretty terrifying because we need the slant height for the surface of the cone. So the surface of the cone has the slanty, curvy side. That is pi times the radius times that weird, funky, loopy thing, which I don't think they've ever really given a name to. I suppose I could look it up on the internet, but I'm not going to. So we have that slant height. Let's use Galaxy Pen. Galaxy Pen! This rounded, curvy cone part is this. That's the formula. Then we want this rounded, curvy part. I should do that in a different color. We'll do that with Rainbow Pen. I should have done Rainbow Pen for this cone because rainbows have kind of an arc to them. That's okay. And then the third part of our doohickey is, we'll use this color, is the circle. So we have three pieces here. We have the cone, we've got that formula, which is going to be let's see, why did they do 2? 2 pi RH. Yeah. So this curvy thing is 2 pi times r times the h. Rainbow pen. So there's that piece. And then we're going to add those two, and then there's the circle on the bottom, which is pi r squared, the area of a circle, which we're going to circle in that color. So we have all three of these pieces added together. Shall we see it? We shall. So pi times r times slant height. The slant height is, the radius is 12. What color am I using? This one. So the radius is 12. The slant height is 25, and then we have pi. So 12 times 25 is 300 pi. 300 times pi is that surface area. Next, we have 2 times the radius times the pi, or times the height. So the height of the cylinder, we've got to make sure we're keeping our heights straight. So 15 is the height of the cylinder times 12, which is the radius again, times d, which is the 2. 2 is 2. So we have 2 times 12 times 15 pi equals 360 pi plus this piece, pi square, or r squared. The r is still 12. Square it, you get 144. 144 pi. We have 144 times pi plus 360 times pi plus 300 times pi, so we can factor out the pi. So we're going to get 660 plus 144. If I get this wrong, I guess I will just start over. So we get 1164 pi. Let's multiply that 3.14. I did get it wrong. Okay, what did I get wrong? I got each term correct. I must have added wrong. Let me try again. I got each piece correct. 300 pi, 360 pi, plus 144 pi. All right, 300 plus 360 plus 144 equals 804. I must have mistyped on my calculator. 804 pi. I must have missed a key. How do I get a, I don't know. 804 pi is all right. I felt like I was doing something wrong. I just felt wrong to me. My intuition was correct. So 344, they said, to approximate 3.14. So we have 25 rounded up. Is approximately equal to 804 pi. All right. If you are rejoining us, welcome back. Welcome back if you are rejoining us. We are moving on to the next page. Oops. We're on page 165. So example 19. Example 19 says solve a real-world problem using a composite solid. A wooden toy is made up of a cone attached to a hemisphere with a diameter of 10 centimeters. The slant height of the cone piece is 13 centimeters. What is the surface area of the toy? Use 3.14 to approximate your pi. Round your answer to the nearest tenth. Enthusiastic math student says, hey, we gotta do the surface area of the toy. Then we need the surface area of the hemisphere plus the area of the lateral surface of the cone. However, I want you to note, enthusiastic math student, I feel like is missing the part that the base of the hemisphere and the base of the cone are touching each other. So we're not going to be adding that base to the surface area. Capiche? Make sense? Verstehen? Comprende? That's all I know. I should learn Latin. Probably has something to do with comprehend. Someone will shoot me a comment, I am sure, about the Latin word for understand, to understand. Comprehend. All right, so the radius of the hemisphere is half of the diameter. That's the first step. The radius is 5 centimeters. Grief. All right, radius is 5 centimeters. So the surface area of the hemisphere. So remember, the surface area of a sphere is 4 pi r squared. I do believe that all your formulas that you will need are on page 169. So C page, actually, tell you what, let's use this fat color. Page 106, niner. I'll make that 9 nice and loopy. Will that help you remember? Page 169 is your formula page for memorizing. You can make flashcards, you can drill that in your head. But the surface area of the sphere is 4 pi r. So a hemisphere is going to be half that, and that does not add the base to it. That just takes the base. The base is not even a part of that equation. So 4 pi r is the sphere, hemisphere. So 4 pi r is our surface area of the, pi r squared, excuse me, 4 pi r squared. That's 4 times the area of a circle. So if it was a circle with a radius, multiply that by 4, you have a sphere. Why is it 4? I don't know. We added 3 dimensions to it. That's not even true. Don't even use that. That's wrong. It's 4 pi r squared. It's 4 pi r squared. Oh my gosh, you guys, I'm tired. All right. 4 pi r squared. We divide that by 2 to get a hemisphere. So it'll just be 2 pi r squared, or we could, let's leave it whole, and then we'll put a 1/2 here. Come on, marker thingy. I blame the marker thingy, not the user. The user is not making mistakes right now, and is also very good looking. 4 pi r squared, half of that. That is the surface area of the sphere. Next, the slanty thing of the it's pi times the radius times the slant height. It's like an L for slant. I don't know. So we have to add these two bits together. So they do that. They plug in the numbers. So we can combine these terms pretty easily, right? So 4 times 1/2 is 2. So we have 2 times pi. The radius is 5. So the radius squared is going to be 25. So the surface area of this is going to be 50 pi. It's general best practice to just leave the pi until the very, very end. That's a good practice. So 50 pi, leave the pi, because you're going to get nasty little decimals if you start multiplying your pi all over the place. Leave your pi whole. The next piece is, and if you're not listening to me on double speed by now, you should do that, because I feel like I'm going really slowly. Or at least 1.5 times my speed. The next piece is pi r slant height. So pi, once again, is still pi. The r is still 5, but we're not squaring it this time. So 5 times the slant height of 13. 5 times 13 pi equals 65 pi. We add these two bits together. We're going to get 115 pi. And then they said to use 3.14 to approximate. When you multiply that out, you get the answer of 361.1 cubic square centimeters, because we're doing surface area. It's like that. All right, guided practice number 2. Do it now. welcome back. You've done it. Good job, you guys. I'm really proud of you. I'm glad you've done it. For me, the passage of time was like mere seconds, but for you, who knows? Not I. Yeah, we'll go ahead and erase this too. So, she says, a Boyd house looks like a cube with a square pyramid on the top. Square pyramid. As shown, the birdhouse has a circular entrance with a diameter of 4 inches. Did you forget that the diameter is twice the radius? If so, you might pause again and redo it. Find the exterior surface area of the birdhouse. Guys, we have 3 pieces that need to be solved here. It's a 10 by 10 cube. Your answer is set about, oh, they say, what do they say? Round to the, I don't know, it's 747.44 square inches. Gotta practice too. I have a feeling most of us are going to need to do this. This one is really challenging. So we have a cube. We got a pyramid up here. Oh, I didn't give myself the space. Whatever. So we're just doing the surface area. So guys, forget about 3 dimensions. We have 2-dimensional shapes that we're working with right here. We've got triangles. We've got 1, 2, and there's 2 in the back. 3, 4 triangles. 4 triangles. We've got squares. How many squares do we have? Well, a cube has 6 sides. One of them is covered up by this pyramid. So we only have 5 sides. There's going to be one on the bottom. Boop, 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 boop. The one on the bottom. Boop, 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 boop. 1, 2, 3, and then 4, and then 5. Right? So we have 5 squares. We also got to reckon with this little thing right here, right? We got a circle. But is it a circle? I think it's a negative circle. I'm going to draw it in red because it is negative. 1 negative circle. It's actually literally negative. It's like a negative area. So I don't know if you remember, we talked about, like, can you have dimensions of a square that are negative? Kind of, sort of, but not really. But kind of, sort of, yeah. Sometimes you have to deal with things at negative numbers. And I don't know, maybe it's helpful for you to remember that the circle is negative. Or we have to subtract it. Whatever, however you want to remember that is fine. I like thinking of things as negative because it's just the kind of person that I am. I'm a negative kind of person. So deal with 4 triangles, 5 squares, and 1 circle. That looks like 10, doesn't it? Let's redoodle that. We'll redoodle it so it looks more whole-ish instead of 0-ish. Now it looks kind of 6-ish. I strive for accuracy in everything that I do. All right, what's the area of the square? Because that's easy. Square is 10 by 10, right? 10 by 10, each square is 100. There are 5 of them. We got 500. Done. Check mark. Oops. I'm running out of space here. I'm going to have to shimmy over, sashay over this way. Let's do the triangulars. The triangle, they say it's got a height of 13. So it's 13. So 1/2 the base times the height is the area of the triangle. So we got 1/2 times the base, which is 10, and the height, which is 13. So that's 130, combining those two. Half of 130 is, hang on, don't tell me, shh, no, I said don't tell me. I was gonna get it anyway. It's 65. Now let me double check, because last time I did mental math, it was supremely wrong. So yeah, 10 times 13, I'm literally doing this on my calculator just to be sure. Divided by 2, 65. I'm right. We're gonna multiply that by 4, you guys. We have 4 triangles. Don't forget that step. So we have 260. Times 4 equals, let me rainbow pen circle these, because why not? So 65 times 4 is 260. Circled with a rainbow pen. And then we have this negative circle. What's the radius, you guys? Oh, it's 4, right? Wrong, it's 2. So pi r squared, 2 times 2 is 4, times pi. So we have 4 pi. They don't tell us how to approximate our pi, so we're just going to do it however we want to do it. If you want to do actual literal pi on your calculator, 3.14, help me out, Alina, 3.14, 15926535897932384626433832795 equals 12.57. I'm just going to the hundreds. Shout out to my homegirl Alina doing all them pi digits. Oh man. All right, 12.57. There's only one, but hey, remember we're subtractifying it. It's red because I said so. So we have 500 plus 260 is 760. We're going to subtract that 12.57. And we nailed it, you guys. 747 and some change. Summate 747. Every good 7 has a mustache. And 4 and some change. 1/10 of an inch is fine. These are inches squared. Square inches. Whew, that was fun. All right, y'all. All right. Dudes and dudettes. 1 page to go. It's not so bad, is it? Page 166. Example. Zwanzig. That's German. There's a candle holder in the shape of a cube with cylindrical, that's adjectival, cylindrical hole through the middle. The edge length of the cube is 15 centimeters. The height of the cylindrical hole is 9 centimeters. And the radius of the hole is 2.5 centimeters. What is the volume of the candle holder? Use 3.14 as an approximation for your pi. Round your answer to the nearest centimeter, cubic centimeter. So remember that last time when I said save your pi for the end? This time there's only one thing that we're dealing with that has a pi. Only one thing that has a round jobby. And that thing is the cylindrical hole. So there's really no point in, it doesn't add any benefit to save your pi to the end. You can do it still because, like I said, it's a good practice. But, I mean, it's neither here nor there. It's really neither. More like down to here. That's okay. Okay. Yeah, about that. Okay, so what we're looking at here is a cube, and we have to subtract because we have this this negative hole thing that has color to it. Colorized. So it's negative. It's a void space in our cube, our little candle holder. So the volume of the cube. That's so weird. What's that symbol that they're doing? Oh, edge length. Okay, so apparently for a cube, this little swirly symbol is the edge length now. Whatever. You take that and you cube it. Cube it to find a cube. That's why they call it cubing. Multiplying something by itself 3 times. So 15 cubed gives us the volume of the deal, which is 3 3,375. Every good mustache needs a 7, or strike that, reverse it. The volume of the cylindrical hole is pi r squared times the height. You plug that in. R squared h equals 2.5 squared times 9er times the pi, which equals, calculator to the rescue, 2.5 square is 6.25 times 9 equals 56.25 times 3.14. We're going to get 56.255 pi, which is approximately equal to 176. They said around to the nearest centimeter. So so we're going to round it up to 177. 177. We're going to subtract this because this is the void, remember? Subtract it from that. So 3375, or you can just say minus 3375, and then remember that you're not dealing with a negative number, you're dealing with a positive number. We're going to get 3,198. And because it's an example, it's handy to do it along with the book to make sure that you can go through the steps. I know it's late in the school year for me to be mentioning that for the first time, but we're doing it. We're going through these steps because they miss, don't they? They put a decimal point there in the book, and they should have put a comma. Whoopsies. That's about 3,198 cubic centimeters. Final answer, and I'm sticking to it. That's the volume. Guys, pause it. Do guided practice. Whoopsies. Guided practice number 3, and then we're going to call it a day. Good work, everybody, I assume. All right, unpause. Show up. Heads up, eyes up, effort counts twice. Let's not forget all these liturgies we got going on. Guys, this time there's a cone. Once again, we're just subtracting one volume from another. The solid shown is a cylinder, but it has a cone-shaped hole drilled in it. How one drills a hole the shape of a cone, maybe they don't drill it. Maybe it's a cast, and they cast the cone in a relief. That would be the way to do it. Do a cast. All right. The diameter is 22 centimeters. Its height is 15 centimeters. The radius of the cone-shaped hole is 7 centimeters. The height is 10 centimeters. Find the volume of the solid. Use 3.14 as approximation for pi. Round your answer to the nearest cubic centimeter. Hopefully you were listening to me on 2 times speed, because that would have sounded amazing that fast, I think. The answer, guys, is 5,186 centimeters cubed. Cubic centimeters. Yeah. There you go. So if you got it, great. Congratulations. You have my permission to stop watching. If you want to watch me do it, here you go. All right. I'm looking over a 4-leafed clover that I've overlooked before. I don't know if it's always helpful to draw it. Like I said, I'm super visual. Sometimes it helps me to get exactly what I'm doing. I know there's a picture in the book, and that is handy as well. Whew. Okay, let's label our dimensions. 15 is that. 10 is the depth of this point thing. 22 is the diameter, which means my radius is 11. I'm just going to leave it as radius because no point confusing myself, right? The radius is 11. They give us the diameter. We tell them to take that diameter and shove it because we need a radius, not a diameter. And this radius up here is Sibin. All right, let's get to work. So the area of the cylinder is pi r squared. So cylinder first. Pi r squared times height. It's the area of the bottom circle. The area of the bottom circle times how high it is. And we know the circles are the same, so it's just that many circles stacked on top of each other gives us our thing. So the radius is 11. I'm going to start plugging things in. 11 squared times 15. I'm just going to punch this into my calculator. 11 squared, or 11 times 11, is 121, times 15 equals 1,815. The ones need hats and shoes, because that's how I do it. 1,815. From this, we're going to subtract the volume of the cone. The area of the cone, or excuse me, the volume of the cone is 1/3 times the base times the height, which is the same formula as a cylinder, except it's 1/3 as big. Times 1/3 pi, pi r squared. That's the base. That's the height. That's our b, that's our h. Capiche? All right, capiche. This time we're dealing with different heights. The height is 10. 7 squared is 49. So 49 times 10 is 490. I'm going to take 490 divided by 3. Let's not forget pi. So 490 divided by 3 equals 163 and a third. 163, we'll just put 0.3 pi. Yeah, so let's not forget our pi's. 1,815 pi and 163 times pi. So the total amount of pi we have is 1815 minus 163 pi. So that's pi, equals 1652 pi. So 1652 times pi, and actually, yeah, that's right, times 3.14 equals 5,187. I'm off by, oh, of course I'm off by 1 because I dropped off the 0.3, but when you multiply the 0.3 by pi, it's going to end up being relevant. It's going to end up being a whole centimeter again. So I was off by 1. If you did that on your checkpoint, I wouldn't blow a gasket over it, but 5180 centimeters cubic. That's all. Good job, guys. I love you. I miss you. Can't wait to see you again someday before the last trumpet, hopefully. Toodles.